In this video, we'll see how to do what you learned in part 2 of lesson 4 using Minitab. So the first question ask us to find the z-score so that 89.44% of the area is to the left of that z-score. So if you look at the video from part 1, you'll see we did this problem using the z-table. I'll show you how to do it using Minitab. So if you go to graph, probability distribution plot, view probability, and then go to the standard normal. So this is like what your z-table is, mean 0, standard deviation 1. And under options, we want to find the area to the left of a z-score. So we're going to want a left tail. And this is a backwards problem. We want the shaded area under the curve, that shaded area, to be 89.44%. So you want to select a specified probability because the probability is a shaded area. And we're going backwards. We want to find the value on the x-axis, which happens to be a z-score in this case. So the shaded area to the left that you want is 0.8944. Click OK and OK again, and see if this looks reasonable. So this red area, if we want it to be 0.8944, means we're going to need a z-score of 1.25. And if you look again at the previous video, we did see that the z-score looks like this, okay, 1.25. Likewise, to do the next problem, we want a z-score so that 33% of the area to the there's 33% of the area to the right of that z-score. So if we want 33% of the area to the right, you can see that your z-score is going to be somewhere in this range. To figure out what it is exactly, go back to where we were, still looking at a standard normal. We want the area to the right. So click right tail. Make sure that this says a specified probability because you know the shaded area is 0.33. We want to know what is the corresponding z-score. And we can see the z-score is 0.4399. Okay. Okay, so how about the third problem? Here we're told that female heights have a mean of 65 inches and a standard deviation of 3.5, and they're normally distributed. So going to probability distribution plot, view probability, and we can put in the mean of 65 and a standard deviation of 3.5. And then under options, this is a backwards problem. We want to know, what does your height need to be? So the value on the x-axis, these are your heights. What does your height need to be so that you're in the 80th percentile? In other words, that means so that 80% of the people did worse than you. So find the x so that 80% of the area to the left falls there. So again, you want a specified probability. We're doing a backwards problem. We want a left tail. We know that 80% of the area is to the left. We want to know what is the corresponding height. Okay, and we can see here, 80% of the people are shorter than 67.95 inches. The next question is, how tall do you need to be so that you're in the top 10%? Well, that's going to be somewhere about where my cursor is. I know that 10% of the area is going to be to the right of that. What is that height? So it's going to be something taller than 67.95. So just go back to probability distribution plot, view probability, and then under options, click right tail, still specified probability. We want the area to the right of that value to be 10%, to be in the top 10%. Okay, okay again. And we can see to be in the top 10%, you've got to be 69.49 inches.